Hey guys. Again, I'm really sorry that I couldn't make it to our Zoom sessions today. There's a lot of stuff going down at school right now, a lot of meetings, things getting passed down from the board, which you all will find out more about later once it all gets solidified. So I'm going to go over last week's homework, which was section 5.4, which as a group y'all did very well on. You got an 81.7% accuracy rate. That is amazing. So I am going to go over the vocab real quick just to kind of like talk about it again, and then I'm going to go pretty much over the entire assignment, specifically the ones that were scored below 80%. But all the vocab you did well on, but I just want to solidify them for you, okay? So first, a segment from a vertex in the midpoint of the opposite side. So if we're talking about, and all of these are dealing with special segments and triangles. So all of this is special segments and triangles. Okay, we have 4 of them that we're dealing with total, but 5.4 is just dealing with one of them. So if we're going from a vertex, remember a vertex is going to be one of the general 3 points that creates the triangle, to the midpoint of the opposite side, like so. So we're talking about this segment right here. Just remember it, that is called a median. So the way I kind of help remember that is if we're going to just think of it as a segment going to the middle. Middle, median, okay? All right. Next we have, okay, a point of concurrence. Remember, a point of concurrency is whenever 3 lines intersect to 1 point, and we're talking about the point of concurrency if we have 3 medians. So here's all of our vertexes. Remember, it's the 3 original points, boom, boom, boom. And then we have our midpoints. So here's one of our medians. And this is probably not going to be very accurate, so please forgive me if it is sloppy. Trying to get them to all intersect together. This 1 point here, this is your point of congruency. Of 3 medians, it is known. And it's really important for us to be able to identify these right here, because the formulas that we're working with in this section are dealing with being able to identify vertexes, midpoints, and centroids, because you don't know which formula you're going to use if you can't identify those parts. All right. Here we go. Next, we have a segment from the vertex to the opposite side, or the side containing it, in a perpendicular fashion. So if we're just talking about being in a perpendicular fashion, so we're talking about a triangle, and we're going again from a vertex straight down at a right angle. Now, what is, I don't know why I put a degree sign as a 9. Silly. Now this segment here, because it goes straight down, it's got a lot of attitude, so it's an altitude. At least that's what I tell myself. Okay? And of course, there is a point of congruency for 3 altitudes. It is very difficult to draw, so I hope you don't mind if I don't do it. So the point of congruency, remember that's whenever 3 altitudes are going to intersect, and it is known as an orthocenter. It's my favorite one because it's just fun to say. Orthocenter. Go ahead and just remember, math people are weird. Okay. All right, so before we start doing these problems here, I'm going to go ahead and give you the formulas that are involved. Now remember, we have, I think it's 3 or 4 major things we're going to be working with. Our first thing we're going to be working with is vertex to centroid. If I misspell anything, please forgive me, okay? Another one that we can be working with is centroid to midpoint. And the third thing we can be working with is a median. So I want to review what each one of those looks like, okay? Let me get some color. All right, so actually, yeah, that'll do. Okay, so just a reminder, I'm going to color code this the best I can. So vertex to centroid is going to be in this purple, it's more like magenta. Do y'all remember magenta from Blue's Clues? Magenta. Okay, so vertex to centroid is going to go from like an original point to the center, because that's our centroid, okay? All right, then centroid to midpoint, we're going to do in green. That is going from our center to the midpoint. It's that little segment right there. And then a median, okay, a median is represented by the whole thing. All right, so our three formulas that we are dealing with, the easy ones first. So our easiest one would be, let's see, and I'm going to abbreviate these if y'all don't mind. We got what? 2 times centroid to midpoint equals vertex to centroid. Okay, it's one of the easy. Another super easy one is 3 times centroid to midpoint is equal to the median. And then the last one, this is the one that I keep messing up on when it comes to remembering it. So let me check again because I don't want to tell you wrong. I think it's the vertex. I got this. I know I do. I need to post it. Okay. The median. Sorry, I know I'm talking to myself. Please forgive me. I'm just making sure I don't tell you all wrong. It's been a rough day. Okay. Yeah, 2/3. Yes. So 2, 3. All right, so here we go. 3 times vertex to centroid equals 2 times the median. There we go. All right, so those are our three formulas. So what we do is you first want to identify what you're given and what you want to find, and then see which one of these formulas matches up with it. Okay. All right, so here we go. So they want us to find TW. So if you notice, TW is the entire segment. And remember, the entire segment is called the median. They're giving us TE. T to E, so let's see, from the point to the middle. Point to the middle is our vertex to centroid. So when I look at my formulas, I'm looking to see which one deals with vertex to centroid and median. Okay? So if I notice right here, vertex to centroid and median. So this is the formula you're going to use. So I'm going to write this down. I know I'm going to use 3 times V to C equals, and I'm going to abbreviate again, median. So now let's plug in, 2 times median. Sugars. We got this. We got this. So now let's plug in what we know. So we have 3 times, so V to C is 8. Equals 2 times our median, which is TW. Now all we do is solve. So we do 3 times 8. Well, what's 3 times 8? Well, that's 24. Equals 2 times TW. Now to get TW by itself, we divide by 2. And we get our final answer is 12. So it's all about identifying what you have, what you want, and then seeing which of the three formulas lines up with it. So let's keep working on those. Y'all did good on number 7, so we're going to go to number 8. Okay? So we have MV. So MV is going from the centroid to a midpoint. And you're like, how do you know if it's a midpoint? If it's on the line itself, it's a midpoint, okay? These are your vertexes, any of the 3 major points that create the triangle. If it's on the segment, it's considered a midpoint. And if it's in the center, it's a centroid. So we know we're dealing with centroid to midpoint, and we're given JV. JV is the entire thing, and we've already talked about how the entire thing is your. Okay, so I'm going to turn back to that page. We're dealing with centroid to midpoint and median. So let's see. Aha, right here. Centroid to midpoint and median. So here's the formula we're going to use. So I know I'm going to use the formula. 3 times centroid to midpoint equals the median. So let's plug in what we know. 3 times our centroid to midpoint is MV equals our median, which is 33. Okay, so now we want to solve for MV. So to do that, we would divide by 3, giving us our final answer is 11. Okay. All right, y'all did good on number 9. So we're going to go to number 10. This is the last one we're going to do. So we want to find IB. So IB is going from a vertex to the centroid. And we know BL, and BL is going from the centroid to the midpoint. So I want to see which one of these formulas deals with those two. So let's see, right here. 2 times centroid to midpoint equals vertex to centroid. So here we go, we're going to write that down. 2 times centroid to midpoint is equal to vertex to centroid. So let's plug in what we know. So 2 times centroid to midpoint, which is 8.4, equals vertex to centroid, which is IB. Okay, well, what's 2 times 8.4? Let's see, what, 16.8, and there's nothing else to do. That's our final answer. Okay, if you still are struggling with these, let me know, and I will create some extra content for you all. Please continue to have an open line of communication with me. You all have been absolutely wonderful. Thank you for being so patient and understanding about our Zoom sessions today. I hope that you all have a very, very wonderful and happy Thanksgiving. Enjoy all the yum yums, and I hope that you get to see some of your family, if not in person, hopefully through face-to-face on the phone or computer. I know my family, we're doing a Zoom session for Thanksgiving, so I've missed you guys, and I'll talk to you next week on December 1st. What? You also have a test next week? But wait till after our Zoom session before you take that test.